Okay, so we're going to talk about how on a coordinate plane, how we could possibly prove that a figure is a parallelogram. On top of that, could we prove if a figure was a rectangle? If we could prove on a coordinate plane that a figure is a rhombus. And then on the coordinate plane, if we could prove that a figure is a square. Now, when we say prove, it means you have to have evidence. You can't just say, yeah, it looks like a square. You know, like show evidence. You can't find that evidence but not write it down either. It can't just be in your head. It's got to be on the paper. So what do we know about parallelograms? Lynn, what's something you know about a parallelogram? 4 sides. 4 sides, okay. Would that be true for all of these? Okay. So I'm going to change my definition then, or my directions. Quadrilateral is a, okay, so I'm going to say we already know these have 4 sides. Now, what makes it a parallelogram, Alex?
The opposite sides and angles are congruent.
Okay, but you weren't here on Friday. On Friday, we talked about what actually makes it a parallelogram. That is true about the parallelogram. It does have opposite sides. It does have opposite angles congruent. But what makes it a parallelogram? John? The opposite sides are parallel. So when I say on a coordinate plane, all of these have like a graph, and you're going to have some points. And you have to prove that this figure is a parallelogram on the graph. So if we need to show that opposite sides are parallel, how can we do that on a graph? What do we know about parallel on a graph, Aaron? Same slope. So we need to show opposites have same if we can show that, we know we have a parallelogram. So that would be what your work would look like, finding the slopes, the opposite ones, same slope. Okay? Now, I'm going to give you a moment to think about rectangle, to think about rhombus, to think about square. If you need to pull out your flip book we made last time to help you, you can. I'm going to go grab this thing off the next door. All right, a rectangle. How would we know something's a rectangle? What is the definition of a rectangle? Jesse.
It is the parallelogram that has 4 90-degree angles.
Oh, I spaced that so weird. It's a parallelogram with 4 right angles. So we need to prove this on a coordinate plane. What shows you right angles on a coordinate plane? I've neat? Distance formula tells me how long something is. But what tells me that I have 90 degrees between two sides? So if they have the same slope, they'll never touch. But it does have to do with slope. What's going to show me that these two sides 90 degrees has to do with slope. Aaron? Perpendicular slope. Opposite reciprocal slopes. Yeah. So we're going to find the slopes. And I'm going to say consecutive sides must have opposite reciprocal slopes. But we got to find all four of them. Now, would that be enough information to tell that this is a rectangle? Lynn, what are your thoughts?
I think you would have to find that a set of lines is congruent, or congruent to each other, and then the other side also congruent to each other. Not all congruent to, not all of the lines are congruent to each other, but there's two sets.
So you're saying we need to make sure it's not a square. Sounds excellent. So now all squares are rectangles. They all are. But if it's a square, I'm going to call it a square. So we want to make sure this is only a rectangle. Then we need to find the length of like two consecutive sides to make sure they don't have the exact same length to make them a square. How do you find length on the coordinate plane? How do we find how long something is on the coordinate plane? It's called the distance formula. So and I can rewrite it on this paper too if you need it again. But we're gonna use the distance formula. To show not all sides are the same length. So if all sides were the same length, it would be a square, so we need to show that it is just a rectangle, not a square. So the distance formula down here, the bottom. Square root. We're going to subtract your x's and then square that answer. We're going to subtract our y's. Square that answer. Add those together and then square root the whole sum. That is the distance formula. Okay. Two more. We've got rhombus. What is the definition of a rhombus, Maggie?
Well, the rhombus has opposite, well, it's parallelogram, but it's consecutive
Look at the very top of that flip book. What's the definition?
Is parallelogram all four sides equal?
With 4 congruent sides. Okay, so what we're going to do though, well, let me start over. How can we start to figure out that this is a rhombus? On the coordinate plane. Hint, I am circling it. What could we start to do? Stephen, what do you think? Distance formula to find what? Uh-huh. Let's make sure all 4 sides are the same. So we're going to use our distance formula. Do you think that there could be a 4-sided figure that only 3 sides are the same? Huh? Like, do I need to actually find all 4 sides? Just curious. All right, so I wrote, use distance formula to show that all 4 sides are the same length. Now, if they are all the same length, it's a rhombus or a square. So how do I know for sure that I've got a rhombus and not a square? Matthew, do you know? That's okay. You want to finish? How can I show that this is only a rhombus but not a square? So how do I show that? How do we show that if something does have right angles? Because we had to do that with rectangle. How did we show that it did have right angles? So we have to find the slopes. Okay, so we need to show that consecutive sides do not have opposite reciprocal slopes. John, did you have a question? Okay. So find slopes. Show consecutive sides do not have opposite reciprocal slopes. And then finally, we got square. Emily, can you tell me the definition of a square? With 4 congruent sides and 4 right angles. So how will we prove that something is Rakaya? When you have a second. We need to see that consecutive sides have all opposite reciprocal slopes. So find slopes. Bless you. Okay, so that takes care of the perpendicular part. Denise, what else do I need to do to show it's a square? To do what? Hmm? So I have a review worksheet for you today. I'm also, once I turn this off, going to collect some things from last week. Just letting a couple of you still write some things down. All the review worksheet should all be review, with the exception of this. Would be the only thing kind of new, but we just went over, didn't do it. We went over how to do it. So like at the back page of your review worksheet, you'll prove LMNO is a parallelogram. And there's a graph for you, but you have to show in the rest of this area, so to prove it's a parallelogram, opposite sides are parallel. So you have to find the slopes of the opposite sides and say, you know, side LM and side NO have the same slope, to prove that they are parallel. Okay? So that's what goes in all of these boxes besides just graphing. You want to use this stuff. All right, if I start with this, that'd be a good place to start. If you just want to start at the beginning, that's up to you. That is our assignment for today.